You know, El Nino was recognized and named a long time ago, but off the coast of South America, the fishermen were really first to spot it, because there'd come a period, in December, for example, there were no fish to catch, nothing to eat. So there's been a change in the ocean currents. So let's look at this graphic and I can explain to you what's going on. Now, in the top graphic there, on the bottom, you can see the flow in the lower levels coming across the ocean and then going up, lots of nutrients coming up, feeding the fish. That's the wind blowing from the east to the west, and that's a normal pattern. It shoves to the west, water piles up out there in the west. And in some cases, that water piles up and eventually gravity takes over, and that helps that surge of water to come back across. But there's your normal pattern, top one. The bottom one, the wind is blowing from the west to the east, and it takes that surge of water across the ocean. It's been known for many, many years, and we nowadays call it El Nino. How does an El Nino form? Well, the searing heat, and I mean searing heat from the sun, warms the tropical waters. Now, the predominant low-level winds blowing from the east to the west shove the waters across the western Pacific equatorial area, eventually piling up. It actually piles up the waters into what we call a warm pool. The warming waters expand, causing a further sea level rise to a level higher than it is in the eastern Pacific. The event increases evaporation that puts increased moisture and heat into the atmosphere, and that helps to cause increased thunderstorm activity. Upper air changes in temperature and moisture and pressure help to cause the upper level winds to change position. Eventually the normal winds change and gravity takes over, and the warm pool, as it tries to level out, it kind of collapses and starts heading on off to the east. At this point, the warm water pool and its entire elements move to the east, taking with it that powerful natural engine that tries to balance the forces of nature that have been disturbed. It is Mother Nature on stage performing a rebalancing act of mammoth proportions. We do a lot of talking about El Nino changing the weather patterns around the world. Let's see some of those impacts. On this graphic, and it's brief and doesn't cover everything, but on this graphic, we can see west coast of Alaska, many times it's warmer than normal. And then sometimes the southwest coast of the United States back into California is wet. In our part of the world, sometimes it's cooler than normal and wetter than normal. And we can see impacts in the northeastern part of the country. And then we get down into South America, and we get into Africa, and then we move out to the west, sometimes dry, sometimes very wet. It does modify everything, but the problem you have is all these El Nino and La Ninas present different pictures of themselves. They're not always exactly the same, and I guess that's what makes it fun to deal with. Right now, you are looking at weather zones, and we'll be talking primarily about the zone South Central, and that's going to be called the South Zone. Now we'll look at 1997, 1998, since it was one, hoss of a El Nino. Now, the red areas there indicate warmer than normal temperatures, even down into Oklahoma, northern plains, the northeast. Amazing stuff. Then we take a look at the precipitation. The hashed in ones were above normal, in fact, quite above normal. Some areas drier, some areas very wet. We see California was wet during that particular time frame. They had horrendous weather. We were wet, and the southeastern part of the country was wet. Now let's focus in a little bit closer. Let's go to the southern region, Oklahoma, Texas. Now, during that 1998 El Nino, the South Division, ours, had an average temperature, add it all up, 45.7, and the normal temperature for that time of year is 43.1. So well above normal for our zone temperature-wise. Now let's take a look at precipitation. Southern region. During the 1997-1998 El Nino, we had 9.67 inches of rain on the average, and the normal is 6.88. So we were wet and warm. Big El Nino does not necessarily mean the next big El Nino will be the same. Zooming in a little bit closer, Oklahoma City and vicinity, that central zone there. Now the average normal rainfall over a 102-year period, 3.76 inches. Now the El Nino years averaged 5.19. So what it's saying there, most of the El Ninos produce precipitation, sometimes get us up there above normal. So the percent of normal was 138%. So wet based on El Ninos that went back to 1914 through 1994. Now looking at El Nino events 1915 through 1992, central zone of Oklahoma, the 102-year normal for that time frame, 5.11 inches. El Nino averaged 6.29, so pretty close to normal on those. But when you average it all out, the percent above normal, the normal percentage, 123%.